A uniform rod of mass m and length L rotates about the horizontal plane with an angular velocity omega about a vertical axis passing through one of the ends, the tension at the rod. If I consider a rod over here of length, let us say L, it is rotating about this axis. Let me say the point is equal to O. So if I want to find out the tension at point X or a distance X, I have to divide the rod into two different parts. Okay, एक तो लेफ्ट हैंड साइड रहेगा यहाँ पे of mass, let us say m1, and on the right hand side the mass is equal to m2. The m2 mass is very significant. So basically I can divide it into two different points. If I separate it, I can divide this mass into slightly different points. तो यहाँ पे ये वाले राइट हैंड साइड पे एक टेंशन एक्ट करेगा which will be equal to T, and this tension we have to find which is at a distance x from the center point, okay, which is at a distance x from the point O. So basically the mass of this rod, now the mass per unit length lambda will be equal to the mass per unit length lambda will be equal to m, the entire mass, divided by L. So over here the entire mass divided by L. If I take for this mass, that is I want to find out the m2. अब यहाँ पे if this distance is x, this distance will be equal to L minus x, okay, this distance will be equal to L minus x. So this is the mass of the rod. Now over here m2 can be written as lambda L minus x, okay, lambda L minus x. This is the mass of the rod, this is the mass of the rod on the right hand side, which is m2 is equal to lambda L minus x. If I consider the center point of this rod, okay, because the centripetal force will act at its center point, which will be at a distance of, if I consider this distance, अगर ये पूरा distance L minus x है, so this distance will be equal to L minus x divided by 2, okay. तो इसका जो distance है, and this distance is x, so इसका जो distance है center से, इसका जो distance है center से, that is r, that is r is this distance from the center to the from the center to the center of mass, from the center of rotation to the center of mass, it will be equal to x plus L minus x divided by 2. So basically it will come out to be L minus x divided by 2. It will come out to be, basically it will come out to be L plus x divided by 2. Basically it will come out to be L plus x divided by 2. Okay. Now over here the tension is the only force which is acting in the left hand side direction. So it will be the resultant force which will be equal to m omega square r. Okay. Now if you see the final answer is in terms of omega, so I am deriving it in terms of omega. So tension will be equal to m omega square r. So tension will be equal to mass, that is m2 omega square r. So m2 का mass यहाँ पे था lambda L minus x into omega square r. R will be equal to L plus x divided by 2. So L minus x into L plus x, let me separate this part first, lambda by 2 omega square, it will be equal to L square minus x square. So basically it is option number D, half m omega square divided by L in the bracket L square minus x square.